Hey guys, so this is a video for 8.3, which is all about integrating with trig functions, and some of these are going to be a little different than what we've been dealing with, and it's going to involve some pre-calc. So I'm going to do a little quick pre-calc review with you. I don't know if you remember these formulas, and if you're taking the SAT, these might come in handy as well. So if you see sine of 2x, that's a double angle formula, and so you could just memorize that. I'm going to show you where that formula comes from, and same with cosine of 2x. This also ties into that cheer that I talked about when I had you in pre-calc. So it's, you have sine of x plus x, which is 2x. It's sine, cosine, cosine, sine. And then with cosine, it's cosine, cosine, sine, sine. With sine, the sine is the same. With cosine, the signs are not the same. The reason I'm mentioning this, you're going to see in just a sec, this is what we're going to be using today, are these formulas. So this is my double angle formula, and where that comes from is using this trig sum formula, and you can simplify this to be 2 sine cosine. Okay, so we could actually say sine of 2x equals that. With cosine, you cosine squared minus sine squared, and that's cosine 2x. Now also, a little bit more pre-calc. If you remember those trig identities, your Pythagorean identities, you know that sine squared plus cosine squared equals 1, which means 1 minus cosine squared or 1 minus sine squared equals the other one. So I could even rewrite this to be, let's see, if I want to solve for, let's say, cosine 2x, let's say I turn everything into terms of sine. So I'm going to turn this cosine squared into a 1 minus sine squared. Then you can combine like terms, so 1 minus 2 sine squared equals cosine 2x. And I can get sine squared by itself by subtracting 1 and then dividing by -2. And this would even be equal to, you could flip this around. You could do -1 plus cosine 2x. There's a lot of algebra here. And you could factor out a negative, which would be 1 minus cosine 2x over 2. So you're probably thinking, oh my gosh, I don't want to do all this. And that's fine. You don't have to. The reason I'm showing you all of that review, like I said, you might see it on the SAT, but more importantly, I'm going to have these formulas in our notes. So that is what's coming next. So you should have this little half sheet of paper. And that's where these formulas are coming from. That's why I just went through all of that, so that you could understand why this is true. And so this is also a little reminder of what I was talking about before and how you can solve for each one. So that's what we're going to be using. And so the first example I have, and there are some different cases, some different scenarios that you'll run into, and that's what we were talking about here. So these are kind of like your 3 different cases, and we're going to be using these formulas with those cases. So this is a case 1. If you have sine cubed and cosine to the 4th, one thing you can do is think about those formulas that you have. So we have formulas for sine squared. So what I'm going to do is rewrite sine cubed as sine squared times sine, and then I'm going to keep this the same. And the reason I'm doing that is so that I can replace sine squared with 1 minus cosine squared. You're probably thinking, like, why are we doing this? And you just kind of got to trust me and follow along, and you're going to see soon enough why we're doing that. Okay? So I replaced sine squared with 1 minus cosine squared, kept everything else the same. And the next thing I'm going to do is I'm going to factor out not really factor out, I guess. I'm going to distribute, okay? So I've got this, let me rearrange these pieces a little bit. Let's get my thoughts together. So we've got all this cosine stuff going on together, and I'm going to kind of group that. Just a lot of kind of algebra manipulating this, okay? So I've just regrouped it. I'm going to distribute now. To the 6th. So I distributed that. And now what you can see is if I take the derivative of cosine, I'm going to get negative sine. Okay? So it's some u sub stuff. Now, I know what y'all are thinking. You're probably thinking, well, why don't we just make u sine? That's not going to really help me because I have all of this going on. This is obviously the more complicated part. So I want to make u cosine. So I'm going to say u is cosine, which means du is negative sine. So I'm going to rewrite this with u's. U to the 4th minus u to the 6th. And what is nice is that this sign canceled out with this sign, but I still have to account for this negative, so I'm just going to plop that out front. And now we're just dealing with a basic power rule problem. So take care of that. Plus c, and then you can substitute back in the u. So negative cosine. I think I was going to do a parenthesis, but I'll just make it a c. And that's it. That's what we're doing. So this is one case where you can break down sine. If you see sine squared, you can replace it with 1 minus cosine squared. Kind of regroup it so that you see all the cosine stuff together, distribute, and then use u substitution. All right, let's try the second case where cosine is odd and positive. And that was on that little sheet of paper talking about the different cases. Okay, so for this one, I'm going to break down cosine this time. All right, let's see. So, and the reason that this is going to work for this problem and what we did last time is not going to work for this one is because if I replace that sine squared with a 1 minus cosine squared and distribute, that u substitution part's not going to work out as nicely. So this time I have 2 cosine squared, so I'm going to replace both of those with a 1 minus sine squared. And I know what you're thinking. I know you're thinking, how am I going to know which one to use when? And that's what the cases are for. So until you kind of get a feel for what's going to happen, just stick to those. Okay, so something that I see is that we can FOIL. So go ahead and FOIL that out. And once we FOIL, you can actually distribute this. So take a second. I'm actually going to pause this real quick for the sake of recording. Why don't you go ahead and FOIL? And we're back. So I FOILed, and then I distributed, got this guy. And so now I'm going to make u be sine, because that's the more gross part. And what's nice about this one is derivative sine is just cosine. So I'm going to replace all of these things with a u. This is going to be the easy part because all I have to do is use power rule and then substitute back in. So go ahead and do that. Cubed and then you just sub back in that sign. So for the sake of time, I'm not going to do that. I'll let you guys finish that out. I do want to show you case 3 quickly, and then next time we'll just work on doing some more of these together. So case 3 is if the powers of both sine and cosine are even and positive. And that's when you're going to use some of those double angle formulas. Okay. So I'm going to rewrite this because this is cosine squared of 4x, and this is what really makes this one different. I'm going to rewrite this as 1/2 1 plus cosine 8x. Okay, so these are going to be equivalent statements, and that's what you need to remember. This goes back to those formulas that you saw in the beginning, where we said sine squared is equal to 1 minus cosine of 2x over 2. What I'm doing is I'm just factoring out a 1/2. So if you want to rewrite those formulas with a 1/2 factored out, I just feel like that makes it easier when you're integrating. And what's always going to happen is that this is just going to be double whatever that is. Okay, so let's see, what can we do from here? We can do u substitution. So we're going to say u equals 8x, which means du is 8. And so I'm going to replace everything with, let's see, with a u. I can go ahead and integrate that 1. Let me get rid of this integral sign. Sorry, sometimes writing and thinking at the same time doesn't work out too well. So I'm going to integrate 1, and then I'm going to go ahead and integrate this guy. You could do u substitution, but at this point, I think we've gotten really good at just being able to kind of do this part in our head. So I'm just thinking reverse chain rule. So I'm going to do 1/8. And let's see, the antiderivative of cosine is sine. And I'm going to keep the 8x. If you want to actually do u sub, that's fine. That's where I'm getting this from. But for the sake of time, I'm going to just jump to this. And what else can we do? That's pretty much it. If you want to redistribute the 1/2, that's fine. And classic mistake, don't forget your plus c. So you can redistribute the 1/2 if you want. You can also leave it factored out. Same thing. Okay, so those are the 3 different cases. We'll focus on doing more of these next time. If you want to rewrite these formulas up here as like what I was talking about earlier, that might help. Because, let's see, sine squared is the same as 1/2 1 minus cosine 2x. And this is the same as 1/2 1 plus cosine of 2x. So we use those with those last cases where you have like cosine of something. And so if you see 4x in your formula, it's going to be an 8x, just like that last one. So hopefully that makes some sense. Just kind of try to get familiar with your different cases, when to use each one. Maybe even cover up the work that we did and retry those. That would be a great thing to do. And next time we'll just practice some more.